Good morning, everybody. It is time for more sine law, and now we are upgrading to see what happens when we get oblique angles or oblique triangles or obtuse angles. Which brings me to my very first question for you. What's an obtuse angle? Come on. Oh, don't use your phone. Obtuse just means an angle between 90 and 180 degrees. I always think of them as like a laid back angle, right? Anyway, we're going to get there. Just hold on. So I'm updating all the notes because Mark showed me some cool science tricks or some cool math tricks. Boop, boop. So this will change. You'll have the actual right one. All right, calculator time. We need to do the sine of 30 degrees. Sine 30. Okay, 0.5. And now we do sine 150. Oh, weird. Also 0.5. 390. Okay, for those that want to know, you start with an angle and you go all the way around. That'd be 360. So it's a little bit more. Nothing we're going to have in a triangle, but I'm trying to make a point here. Sine 390. And I feel like I should change that to a different number, but let's try sine 510. 0.5. So my point is, there's a lot of different angles that have, when you take the sine of them, they have the exact same answer. Your calculator is not nearly as clever. Your calculator, what if you say shift sign to find the angle that goes with this, it's going to give you 30 degrees. It'll never, ever, 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 ever give you 150 or 390 or 510. It always just gives you the smallest one. So sometimes you have to adjust. It's easy. Okay. You can see there's more than one angle. It has the same value for sine since we're doing triangles. Less than what is the sum of the angles in a triangle? Yeah, 180 degrees. So those are never going to be your issue. All right. So there's always going to be two angles. All right, give me time. Less than 180 that have the same value. Okay. So we saw that sine 30 and sine 150 are both 0.5. But notice if you add 30 to 150, you get 180. This will become important. All right, sine 60. Sine 60, 0.86. 8660. Remember from old school when you have to write out, you actually have to write out the value of a trig function, go 4 decimals. Now, I suspect sine, whoops, nope. Try again, sine 120. Hey, look, it's the exact same answer. 0.8660. And notice, if you go 180 minus 60, you get this one. I'm not a fan of subtracting for some reason, so it's completely cool to just figure out, okay, what angle gives me, when I add them together, give me 180. Same answer. All right, sine of 50. 0.7660. Now, if 50 and 130 make up 180, then I know this is 0.7660, or just because 130 sine 130. And there it is. Ta-da! Okay. So to make sure we're good here, if I do the sine of 10, as I can do that, Please clear. Sine 10 degrees. Shouldn't turn it off. Sine 10 degrees. 1736. 0.7. Okay, to get this other one, they're actually called reference angles. I think the smaller one. Doesn't matter. Matters if you're taking trig or calculus. Okay, this should be 170 because 180 minus 10 is 170. So let's just see. Sine 170. Yep. But again, remember, your calculator is only ever going to give you this row. 0.9659. So 75, what should be 105? 180 minus 105. So when I do sine, it did work. 9659. Yep. Okay. So basically what you have to do is just look at your angle or look at your triangle when you're done the question and say, is it a small angle or is it the biggest angle in the triangle opposite the longest side? And I have to make this adjustment. Cool thing is you only have to worry about it when you're calculating an angle. If you're doing a side, who cares? It doesn't matter. You don't have to make any adjustments. All right. Enough of this craziness. Let's just do these questions down here. Okay. Should work like before. Go ahead, get started. Pause the video. You know the drill. Turn me off for a while. Try it yourself. You should be okay. We've done so many of these. I want side P. I'll make this A. The letters you choose don't make any difference. All I need is that one side where I've got the angle and the opposite side. So A over sine A is equal to little p over sine P. So it's this one. So A is 21, 95. Whoopsies, I lost my sign. Is equal to P, which I don't know, over sine 32. Cross multiply. 21. I feel we may have done this exact question before. Oh well. The point of me doing this specific question is because this is an obtuse angle. And I just want to show you if you're finding a side, your calculator doesn't care. It just does the magic. I want to solve for P, so sine 95. So little p is equal to 21 times sine 32 divided by sine 95. And I get 11.17. And I'm going to make that to 11 is equal to P. So even though excuse me, that's an obtuse angle, it really doesn't matter. My math is, I don't make any changes. It works exactly like it did before. Okay, so try that one. I'll make it A. Makes it a little A. is equal to B over sine B. Do you guys watch me at fast forward? You probably could get away with that. If you've already done the question, you just go and figure out where the answer is. Nope, I was going to cross multiply, but I'll put my numbers in first. 5.1 over sine 100 is equal to B, which is 3.6 over sine B. Notice that even though this has a little B in there, no. That's not the convention we use. That's not the normal way to do it. That's why I flipped to a capital B there. So 5.1 sine B is equal to 3.6 sine 100 divided by 5.1 divided by 5.1. Sine B is equal to, got that light there. No, then you can't see. 5.1 sine. That's all wrong. I was looking over there. I need to look over there. My bad. Try it again. 3.6 sine 100 divided by 5.1. Yay. I just said yay because it's 0 point something. I know if I did this calculation and it was greater than 1, then something was messed up. Okay, remember to finish when you have this sine B. To get the inverse of that, you go second and sine, and on mine I just did equals. And so angle B. So notice the word sine disappears. You put the angle symbol in 44 degrees. Okay, which makes sense. Right, if we look at angle A, it's 100. That's going to be my biggest side. This one's smaller, so that makes sense. Actually, I'm going to go back and just do a quick check on this one. 95 was my biggest angle across from 21, which means this one better be less than 21. And it is. Ta-da! Okay, so far so good. This worked the same. Again, the point of it was we had angles that were over 100 or over 90 degrees, so they were obtuse. They still worked out just fine. All right, thanks for the video. I'm pretty sure the next one is where we're going to have to use those reference angles. Come on, it'll be fun. Join me in the next video.